Let me, okay, so let me start with the new topic, and the new topic that I am going to start is going to be the um sorry, this is going to be doubly linked list. Doubly linked list. Okay. So in now, what do we do in doubly linked list? So in normal linked list, we have only the way moving forward, right? Only one side it was moving, and normally at the last it was null, or you can say none, anything you can say. But this is the normal linked list. In the double linked list or doubly linked list, we have the structure a little change, where first and last there will be three part of each node. Okay, so every node has three part, and so this part is connected to this side, and this part is pointing to this side. This part is pointing to this side, and this part is pointing to reverse side. This is pointing to forward, and this is pointing to the backward side. And last is null, and previous is also null. Okay.
Okay.
Okay. So we have three things in this. Number one, this we say this previous. So previous refers to the location of previous element in linked list. Okay, then there is a data part. So this stores the data, and there is third part is the next part. So next part stores, it stores the location of next element in linked list. Okay.
Okay.
So this is what we are connecting. So now, when suppose if we have a list, so we will means, let's suppose we have first element as 21. So 21, there will be next part in this. So then there will be, let's say there is 25 is there. Then let's say there is 32 is there, and then we have 40 at last. So the nodes will be connected like this will be forwarded towards the front side, and this will be null. And there will be another one where this will be forwarded towards this side. This will be storing this. This will be referring this, and this part is again null. Okay.
Okay.
Okay, and again, you will have like the linked list and circular linked list. The person we will have only the contact of this first node that we will call as start over here. Okay,
Mhm.
so now
Sorry, I didn't hear you.
what we studied in the linked list.
I didn't hear you. Can you repeat again?
Okay, so what I am telling is that whatever the implementation now we are going to do with this double linked list, most of the operations will be very same, right? Since we have the address of the starting one only. So suppose I have to print the linked list. So when I have to print the linked list, what I have to do is same thing. Will take a temporary element, and temporary element will be initialized with the start, and loop will run like while temp not equal to null or none, anything you can write. Do not confuse with the null or none. Both things are
Okay.
okay. So
Mm.
just I'll write it as none, and here then it will be temp is equal, sorry, first of all I have to print the elements. So
Mm.
to print, um, print temp of data, and then temp is equal to temp of next. Okay, so by this is same as what we did in the normal linked list.
Yes.
So the element will start from the first position. So first 21
Stops at the end.
yeah, 21 will be printed. Then temp
25.
first temp will be moved to this, so temp will be here. Then 25 will be printed. Then temp is equal to temp of next. This will move here. So now this temp 32 will be printed. Then temp will move to this. So now temp is here. 40 is printed, and again temp will move to here, and here it will check that, and this condition will become true, and this loop will be ended by this. Okay, so but like this, you can just print the elements inside the double linked
Uh,
list.
1 minute. So in linked list, you have showed two things. One is printing the linked list. The another one is traversing the linked list, right?
Yes, yes.
So this will stops at null. I mean the position before the null, right? It prints everything in the linked list. What does the traversing linked list will do?
See, in the printing, what we are doing is we are applying the condition like temp not equal to null. Okay.
Okay. Mm-hmm.
When we are doing the traversing in the linked list, traversing, or we sometimes I use the word as travel in the linked list. So at that time, condition will be while temp of next, sorry, temp temp of next not equal to none. So
Mm-hmm.
this condition we use when we traverse in the linked list. So why we do this traversing? So in while printing, temp will start at this null. Temp will stop at this null. When this means temp will reach at none, then it will stop. While traversing, temp will stop at this
Last
itself.
question, right?
Yes.
Okay. Okay,
Okay.
okay. Yeah, I got it, but I just wanted to make sure. Yeah,
So
good.
why we are doing this is because suppose if we are inserting a new element inside,
There we are
yes,
using this function. Yeah.
yes. So for that you need to stop at the last. If
Okay.
you reach at the null, then where you will add?
At the end,
Yes. So if you reach at here at null, will
null.
you,
Yes,
then
yes,
you will not be able to add anything. Correct.
yes, yes, yes.
So that's why we are stopping at one position before this.
Okay.
Understood?
Yeah, yeah, got it. Yeah,
Got it?
yeah.
Okay. Now, next. So this is what is means this is same. This function is same as what we created in the linked list.
Okay.
Okay. Now, next, we'll try to hmm, insert the element. So we'll insert the element into the linked list. So next is insert an element. So let's say we are inserting at start. Okay. So right now our linked list is like 21 is there. Then this is 25. This is 32, and this is 40, and this is null. Okay, this is pointing towards this side. Okay, now I am inserting, so this is the starting point right now, and now I am inserting a new element. So new node is here, and new node, let's suppose I have taken new node, a value over here is 30. Okay,
Mm.
so
Okay.
So now what we have to do at the next of this 30, this needs to be stored. This the start of previous of this start should be connected to this, and this will be null again,
Null. Yeah.
right? Right now this
Mm.
is null, right? Right
Yes.
now, right now this
21 is null and
uh,
13 have to be null. Yeah.
yes. So so what we'll do? So here suppose the statements will be like new dot next is equal to start. Okay, then start of previous is equal to new. So by this will be created and this will be created and this will be removed. Okay, this will be blocked. This is
Mm.
done. This is done. Okay.
Mm.
Now, since we are inserting a new element before start, so this start also needs to move over here, correct? So we'll do start is equal to new.
Okay.
Okay, so this
Mm.
you need to maintain this order to keep the consistency. So the first step is new of next is equal to null. Second is the start of previous is equal to no to new, and third is start is equal to new. Okay,
Mm.
so by this start now start will come here, and your list now will be like this is 30. Sorry, then 21. So this will be pointing to this will be pointing to this. Then this is 25. This will be pointing to this will be pointing to this. Then this is 32, and this will be pointing to this. 40. This will be pointing to this will be null, and this will be pointing. So now your start is here. Okay, and this
Mm-hmm.
is again null. Understood this?
Yes.
Okay. Now the next thing that we are going to do, next thing is this was number one. Now number two, insert an element at last. Okay.
Mm.
So so to insert an element at the last, again you have to take a new element and you have to make a node of it. So new will be again I am taking so new element. Let's say I am adding 45 over here. New element. Okay. So when this new will be added, so so what has to be done? First of all, again we'll start with the temp is equal to start.
So for this, we can do like the same like linked list, right? We can run the function which
Yes,
we
yes,
used it.
same thing. Yeah, you can do that as well. So let
Mm.
me write like that only. So we will pass means temp is equal to um travel, and travel function will call, and here we'll pass the start node. Okay. So
Mm.
when this function will be there, when this function will run, so it will um,
Mm.
it will take them at last node. Okay, so temp will start from this position, and at when this function will run, temp will reach to this position.
Mm.
Okay.
Yeah.
And when once temp has reached to the last position, now what you have to do? So now the condition is that your 40 is here, okay, and right now It's this is null, and now we have 45. This is the new node. So this is the new node, and this is the temp node. Okay, so next of this will be none again. Okay, now what has to be done is this new will
Temp
be
is equal to new.
yes. So new node will be connected to the next of temp. Okay, so we'll write um,
Next is equal to
temp
new.
temp of next is equal to new. So
Mm.
this will be disconnected and this will be connected to here. Okay, and so this is the first step, and the second step that will be there as new of previous
Next.
is equal
New
to
of next is equal to null, right?
new of next. Yeah, new of next will be null. That will be done the creation
The
of this.
third step. Okay.
Yes. Okay. So new of
New
previous
of,
is equal to temp. So now this will be connected to this. Okay.
okay. Mm-hmm.
Okay. And then if you want, you can write as new of next is equal to null. So this will be none again. Okay. So
Mm-hmm.
once this entire part will be done, at that point, now our list will be like starting from first of all there is 30, then next is 21, next is 25, next is 32, next is 40, and after 40 there will be 45, and this will be none, and this will be connected to this, 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 this will be connected to this is again none. Okay,
Okay.
got this?
Yes.
Is this clear?
Yes.
Very great, 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 great. Okay, now next we'll take so now you have some basic understanding of what is happening.
Yes. Yes. Yes.
Okay,
Yeah.
so the for linked list we took time, but now for the circular linked list and double linked list you will not take time because now you have the basic understanding.
No.
Okay, so next now we are inserting um, insert at some position. Okay, so let's say somebody said that I have to insert a new element at position. Let's say number 4. At number 4, we have to insert a new node. Okay, so let's say new node is taken, and I want to insert 42. Okay, I want to insert 42. So this is our new node, and fourth position is this, right? So what we have to do? We will travel to this fourth position minus 1 till this point will travel.
Yeah.
Okay, so again will apply a loop while. So first of all we'll start with the temp. We'll start with a temp is equal to start. So this is a start. Okay, so we'll start from this. We'll start from this, and what what we have to do. So we'll apply a loop while we'll take a count also. So here we'll take count is equal to 1. So while count is less than position, so that will be doing temp is equal to temp of next. Okay. So when this will run, temp will reach at this point. Okay.
Okay.
Understood. Now we have situation like um we have a situation like this 25 we have this 32. Okay, right now they both are connected. Okay, so this is connected further, this is also connected from this, so this is there, this is there. Okay, now this 42 needs to come in between this. Okay, here this is 10. Okay, now
Mm-hmm.
what needs to be done is at first step here there will be two three address exchanges will be there. Just understand. So now temp of next this address will go here. Okay,
Mm-hmm.
then um, so this will be pointing. Then address of new will go here to connect this with this. Understood? So
Mm-hmm.
this will be connected to this. This will be connected to this place. And in the same way, previous of this will be this element. Okay, and
Mm-hmm. Where you're marking, I don't see it.
okay,
Okay.
let me remove it, and I'll just mark it again. Okay, so just see that carefully.
Mm-hmm.
Um, okay, I'll take this 42 as new. This
Mm-hmm.
position at this position I'm taking. This is 42. Okay, so this is the new element that needs to be inserted. Okay, so now what will be the condition? New of next will be 32, right?
Temp of next.
32 of previous will be this new. Temp of next will be this new, and new of
Mm-hmm.
this will be this temp.
Mm-hmm.
Okay,
Mm-hmm.
so there are four address exchanges are there. Number one is that this. Okay, number two is this, number three is this, and number four is this. Four address exchanges are there. Okay,
Mm-hmm.
understood. So
Yes.
let me do that one by one. First of all,
Okay.
the first address exchange is that new of next is equal to this 32. So 32 is temp of next, correct?
Mm.
So
1 minute.
temp of
Yeah.
okay. So new of next is equal to temp of next. So this one part, so this is done. Okay. Number two. Now, now next is this is the temp of next, and this position is temp of next of previous. Okay. So
Mm-hmm.
temp of next of previous is equal to new. Okay.
Mm-hmm.
Then third thing is third thing is temp of next will be is equal to new. So this will be done. This is already done. This and this is the third. And then fourth thing is new of previous is equal to temp. Is this clear?
Just a minute. New of next is equal to temp of next. Okay. Temp of next dot previous is equal to new. Okay.
So you can see like this. This is temp and this is temp of next. Okay. So this pointer is for temp of next of previous. So temp,
So you have written temp of next is equal to new. You have to write temp is equal to new, right?
no, why I
No.
should temp is equal to new? I am not moving
Okay.
this new to temp. I am just connecting next of temp to new,
Mm-hmm.
right?
So you are mentioning here the temp of the 32 also temp of next, and then again the temp is temp of also the temp of next, right?
Before connecting, right? Means right now, uh, if just forget these two.
Yeah, I got it. So when once it is got connected, the pointer is changing.
Yes. We have to
Oh,
change pointers.
okay.
Understand?
Okay. Yeah.
Just it will take a little time to understand that what how these exchanges are happening,
Yes, yes.
right?
Yeah.
Do you want me to explain this part again?
No, I'm good, Kushal. I'm good.
Are you able to follow with me? Just keep this steps in mind.
Hmm.
Means this one by one only you have to do in the
Yes.
same order only.
So
If you
same, yes. If we change the order, we cannot execute. It won't be
yes,
correct, right? Yeah, okay.
okay,
Mm-hmm.
understood.
Yes.
Okay, so now after execution of this, your doubly linked list will be like it will be starting from okay, it will be starting from but first one is 30, 21, 25. So 30, 21, then 25, then 32. After 25 there is 42, right? So after 25 there is 42, then 32, 40, 45, 32, 40, and 45. So all are connected. So this is connected, 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 and these two are also connected, and this is null. This is our this is also null, and this is star. Okay.
So I have a question. Can we do like you said the order should not be changed? That's fine, I understand. But
Mm.
can we connect the 25 to, can you go a little bit up? I have a question
Yes,
on that.
yes,
So can we connect 25 to the new node and then to new node to 32?
yes. That you can do.
Yeah.
Obviously.
Okay. Okay, fine. Then fine.
Hmm. So what I have done is I have connected the next node with new node at first, and then I'm connecting the temp node with new node. You can
Yes.
change this order, and first you can try attempting these two addresses, and then you can try attempting these two addresses.
Okay. Okay, fine.
Okay, but um, at the same time, what you have to keep in mind is, give me a second. So what you have to keep in mind is that right now with with
Okay.
with right now with this setup, sorry,
Where we have taken count is less than push and the temp is equal to temp dot next will be at 32. That's the reason you have taken from 32, I think.
yes. So first, so you have to take the consideration of this first. Then you have to take consideration because temp is at this place and you don't have the direct address of this.
All right. Yeah.
Don't have the
Yeah.
this.
Okay. Got it.
So that's why you have to connect this side first. Then
Okay.
you connect this.
Uh-huh. Got it. Got it. Yeah.
Okay, so this side will be the first preference, and then this side you can do later on.
Okay.
So that's why I'm telling this order, not to change this order.
Okay. Okay.
Clear?
Yeah, clear.
So this all part is the certain part. Now we'll go to the removal part.
Okay.
Right? Remove element from first position, right? So to remove element from first position, simply not in a normal, what we do is just we have to move a start to next. So we'll take a start is equal to start of next. So as soon we'll do the start of next. So right now our first element is this 30, and the second element is this 21. This is connected further, and this is connected to this. Okay, so this is start right now, and this is null. So when we'll do so, this element, this statement will be executed. So start will move here. Okay, so now when this is a start, rest is as it is. What next you have to do is you have to make this portion vacant. Right now this is connected to this. So what you have to do is at second part you have to make again a start of previous is equal to none. So as soon you make this none, this will be disconnected and this will be containing none. Okay.
Okay.
So this is removing it from the first position. Okay,
Mm.
clear?
Yes.
Then again the fifth, remove from last. Removing from the last part. So now after removing this 30, we have we our list is starting from this 21. Okay, so we'll again do the traversing till last node. Okay, so we'll go
Mm-hmm.
at temp is equal to temp is equal to, will apply this travel function, travel linked list function, and here
Mm-hmm.
we'll pass the start itself. Okay, so at the ending of this, temp will be at at 45. Okay, so at the ending, uh, oh sorry, temp will be at 45. So this right now this is null. Okay, and so give me a second. Let me write this again. So our position is right now is this is 40 and this is 45. Okay, right now this is null. This is previous of this, and this is pointing to this. So right after completing of this loop, temp will be here, and this is previous of temp. Okay, this is temp of previous. Okay,
Mm-hmm.
right now our position is this. So what we have to do is we have to disconnect this link. This one needs to be disconnected. Okay, so what we'll do is at this point we'll do temp of previous of next is equal to none. So by this will be disconnected and this will be containing none. Okay,
Mm-hmm.
and then we'll do next we'll do temp of previous is equal to none. Okay, so by this link will also be disconnected and this will also be null. Okay,
Mm-hmm.
so now this temp is not connected even to its previous element. Okay,
Mm,
and temp of previous is not connected with temp. Now this is a separate node now.
mm.
Okay,
Okay.
so this is disconnected. Clear?
Okay.
Any doubt with this?
No.
Clear?
Clear.
Next.
Clear.
So next thing is remove from any position. So now let me rebuild the linked list. So now at right now our list is starting from 21 and going till 40. Okay. So I'm just let me make the linked list again. So our linked list is at 21, 21, 25, 42, 21, 25, 42. Then next is 32 and 40.
Mm,
32 and 40. Okay, and this is null, and first one is also null. Okay,
mhm.
right now our list is like this. Now what we have to do, let's suppose I have to remove an element from third position, right? So the position from which we need to remove is position is equal to 3. So again, this right now this is the start. Okay, and here will initialize temp is equal to start and will make a loop to reach this to third position. Okay, so here what we can do, and we can make it reach to the position itself where it want to where we want to remove. Okay, so we'll apply a loop. We'll apply a loop like hmm, while temp. Sorry, we'll take a count over here, not with temp. So we'll take a count. Count is equal to 1 while count is less than position. Okay, and this will be doing temp is equal to temp of next. Okay,
Okay.
by this, now what will be the condition when this loop? I'm taking this equal to over here. Okay, what I want is to reach at that node which I want to delete. So now after completion of this loop, our position will be like there is this is 25, this is 42, and this is 32. Further elements are here, so it will be pointing further. It is getting pointed over here. Okay, and this is also pointing and at many position. Okay, so the node that needs to be removed is temp. This is the node that has to be removed. Okay, so when this is temp, this is temp of previous, and this is temp of next. Okay, yes, no.
Yes.
Okay, so now what we have to do is we have to do this management like um, first of all temp of next needs to be connected with this temp of previous. Okay, this is temp of next, this is temp of previous. Okay,
Mm-hmm.
so temp of previous of next will be connected with the temp of next. Okay,
Mm-hmm.
so at first step, what will we do is what we'll be doing is um, just understand temp of previous of next is equal to temp of next. So by this, what will happen is this link, this link will be broken and this will be connected to this. Okay, understood?
Yes.
Okay, now next is temp of next of previous will be connected with temp of previous. Okay,
Mm. Yes.
so at this point, what will be there? Temp of next
Is
of previous is equal to temp of previous. So by this, this link will be broken and this will be connected to this. Okay,
okay.
understood?
Yes, yes.
Now these four links are there. Two out of them, two are broken. Now we have to break the element, the links which are existing at temp. Okay, so what we'll do is temp of next is equal to none. So by this will be broken. Okay, and then fourth step, what we'll do is temp of previous is equal to none. So by this link will also be broken. So all links are broken and the required nodes are connected together.
Mm-hmm. But
Okay.
here is a question. Temp of next or previous you have written.
Hmm.
Instead, we can write temp of next is equal to previous or next, right? Temp of previous, second
I,
step I'm mentioning.
tell me again what you are saying.
So the second step, we can also write temp of next is equal to temp of previous, right?
No, no, no. Temp of next is equal to temp of previous. We cannot write. Temp of next is right now this. This is the temp of next.
Which you are saying? I don't.
It means this is the link and this is the node which is known as temp of next. So we cannot write that temp of next is equal to temp of previous. We cannot write like that.
Mm-hmm. Mm-hmm. Okay.
Okay,
Okay.
because
Okay.
because this needs to be connected with this. So
Mm-hmm.
this node is temp of previous and this is temp of next. So temp of next of previous. This point needs to be connected to this. Okay.
Mm-hmm.
So that's why
Okay.
I have to write temp of next of previous will be
Mm.
this.
Okay.
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 Understood? Any doubt?
No, I'm good.
So just remember the ordering always.
Okay.
When you will start implementing by yourself, you will understand how all this ordering is working.
Okay.
Okay.
Mm-hmm.
This is little tricky, but very easy. So when if you know the linked list very well, then you will be able to apply these concepts.
Okay.
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 Understood? Any doubt?
Mm-hmm. No, I'm good.
So this part is the entirely double linked list.
Okay.
Okay. Any doubt?
No, I'm good. Yeah.
Okay. So do you want me to show the code, or will you create the code by yourself?
I can create it by myself for the next week. Yeah. That is also.
Okay. What I'll do is I'll share the code with you
Mhm.
directly. Okay. So try to you have 4 5 days. Try to practice all these three code by yourself.
Okay.
Okay, once you will do, then only you will be having the confidence on this.
Okay.
Okay, so I always recommend to implement it by yourself. If you are not implementing by yourself, you will not understand that what is happening actually.
Okay.
Okay, so try to implement by yourself and just you know, keep these logics in mind.
Okay.
This will be very useful for you then.
Okay.
Okay, if you are able to understand this properly, I would I would feel that getting tab for your understanding got some results for me,
Mm-hmm.
right?
Yeah.
Okay, so should I start the next topic in this?
Yes. Yes.
So you are not exhausted?
No, no, no. I'm good.
Okay. So the next topic in this is doubly circular linked list.
But you need to give me 2 minutes. I have to settle down my kid. He's going to.
Sure, sure. Take your time. So now in the linked list part, there are three more things are there that I'm giving you just an overview of this. Just try to make it by yourself. Okay. So the number one now in this is number one is doubly circular linked list. Okay. So, like there was a linked list, then there was a circular linked list. In the same way, there is doubly linked list and there is doubly circular linked list. So now what doubly circular linked list says, so here suppose you have the first one. So you have this first element. Okay, then you have this second element, then you have this third, and we have this fourth element. Okay, so let's say this is 21, 25, 29, and 33 we have. This is connected, this is connected, this is connected. But now, right now, in the circular linked list, this was null and this was null. Okay, but in doubly circular, what we do is in doubly circular, this last element is connected with this first element, and this first element is connected with the last element. Okay,
Mm-hmm.
so like this, there becomes a circle. So this is the starting point, and this is the ending point. Okay. So now first node and last node both are connected like the circular linked list. Okay.
Yes. Mm.
So whatever the programs were there in doubly circular linked list, the same kind of programs will be there in the doubly circular linked list, like circular linked list. The same changes that we do from linked list to circular linked list, same changes will be done from doubly circular linked list for doubly linked list to doubly circular linked list. Okay.
So I'm a circular linked list. We did the same thing, right? What's the
Ye-
difference here?
This is doubly circular. Circular linked list was not the both sided. This is the both
Oh, it's a
sided.
single side. Oh, okay. Yeah, yeah, yeah. Okay.
Okay. So
Mm-hmm.
you have to apply the same logic what we did for the circular linked list. In the same way, you have to apply the logic over here as well for maintaining all the connections.
Okay.
Okay, so can you try making the program of doubly circular linked list by yourself, or should I repeat all the insertion and
No,
deletion?
no, no. Let me look at the concepts. No, no. You no need to explain this one. I can do it. Is what I believe. So I will
Yes.
check on the concepts. If I have questions, I will
Yes, definitely,
do
definitely. Try to
next
implement
time.
it by yourself, and if you have a doubt, let me know. Then I'll clear out your doubts. The
Okay.
same operations you have to do. And then
Mm-hmm.
the second thing comes is the stack. A stack is what? Last in, first out, or first in, last out. Okay. So,
Mm-hmm.
so now what, when we talk about this last in first out, so now let's say, like you have you have a stack like this. So when elements are coming into this, okay, elements are coming into this. So this is 21, 25, 26, 28, right? Like this element has come. So this was the first element, then this is second, this is third, this is fourth. So this was inserted at last. So this will only come out at first. Okay. And the element that has inserted at first will come out at last. So this is what is LIFO. Okay, last in, first out.
Mm-hmm.
Okay, so let me write this. Last in, first out. Okay, so here, right now, you have learned the linked list where we are doing the operation like insert at last, delete at last, insert at first, delete at first, or insert at certain position, or delete from a certain position, right? We were doing the everything. But now you have to make a structure like where you can just insert at one position and delete from that position only. Okay.
Repeat.
So now here in last and first out, what we are going to do is, let's suppose I have a list, linked list like 21. Okay. And I have, let's say, sorry, I have this 26, then I have 31, then I have 34. Okay, and this is null. Okay, this is the starting. So first this element came out, came, then this was inserted, then this was inserted, then this was inserted. Okay, so now if I have to delete, I cannot delete from first, second, or third. First of all, it will be this, the element that has been inserted at last. This only can be deleted. Okay.
Mm-hmm.
So you have to make now when this stack is created, what you have to do is you have to make just two functions. One is sorry, one function is you are going to make will be push, and second function you are going to make is pop. So push is delete element, uh, delete element at last. Sorry, this is insert element, not pushes to insert. Insert element at last, and pop is pop is delete element from last.
Okay.
So now you have to make the same structure like linked list, but you do not need to make the functions like inserting at last, inserting at a start, or deleting at a start, or inserting at some position, or deleting at some position. Only when somebody says that in push an element, just insert an element into the list at the last. If somebody says just pop an element, just delete one element from the last. That's it. So that will become your stack. Okay.
Mm-hmm.
And the third thing you have to, in the third topic in this is queue, right?
Okay.
So queue is uh, queue follows the concept of
So
first.
I had this in engineering. I totally forget. Yeah, I had data success subject in engineering.
Yes, it is there everywhere in engineering. So what you have to do is first in, first out. Okay. So
Mm-hmm.
suppose now you have uh, in linked list like this: 21, 26, 31, and 34. Okay, so now this is null. So, and this is the starting point. So what you have to do is, um, now you the function you will make is uh, delete from first position, and second is insert at last position. So this will be your FIFO, first in, first out. So
Mm-hmm.
so element will go out from here, and element will come over here. So no element can be inserted at the starting, or no element can be inserted at certain position. Element can be inserted only at the last, and element can only be deleted from first position. That's it. So you have to make these two functions only now.
Okay.
Okay. So,
Okay.
so for this week, you have enough work to practice, like
Mm-hmm.
doubly circular, stack, and queues. If you are able to do this in this entire week, next week we'll start the tree and on the Saturday, and by end of next week we'll start the AWS.
Okay. This stack and queue will be starting in the next week. Oh, the
Yes.
graph. Okay.
Okay.
Okay. Fine.
Okay, so just do the practice, and let me know in between also if you need any help with the program. You can ask me. I'll send you the program.
Okay. But
Okay.
you are not sending the doubly circular list. You said you're sharing the code, right?
Yes, I'll share the code W circular link list.
Okay.
Okay.
Okay. Okay. Fine.
Thank you.
Thank you. Bye.